Good morning, everyone. Welcome to our YouTube short video. Today, we are going to understand how the use of Auto EDA libraries can help reduce the time we spent on performing EDA. So, first of all, what is EDA? EDA stands for Exploratory Data Analysis. In simple terms, we can say EDA is like looking at our data with a magnifying glass so that we can understand what is present in our data and what are the interesting patterns in our data and all of those things. So, with a real time example, I'll say if we have a retail sales data set present, so by performing EDA, we can understand what are the top selling products and what are the trends over time and all of those things. And by knowing all those things, we can make better decisions from those. So overall, EDA plays a very important or a crucial role in the data analysis process. So apart from EDA, we are coming to Auto EDA libraries. There are a lot of Auto EDA libraries present. So some of them are like AutoViz, Sweetviz, Pandas profiling, data prep, etc. So the one that I have chosen here is Sweetviz. So coming to the Sweetviz is an open source Python library. So it can be used for free and it mostly used to generate very easy to understand visualizations in just a few lines of code. So while I'm seeing a few lines of code is nothing but it saves us a lot of time and effort, and we will see that in action within a second. So coming to our business problem here, a company wants to improve the overall sales performance and also the customer satisfaction in response to a decline in sales revenue. And the business objective here is to maximize the sales revenue, and the business constraint is to minimize the budget. So, coming to the success criteria, there are business success criteria, economic success criteria, and ML success criteria. Here, the business success criteria is to increase sales revenue by at least 15%, and the economic success criteria is to improve profitability with a minimum 10% increase in gross profit margin while managing the cost effectively. And the ML success criteria is improving the accuracy for about 90%. So, here we have to perform EDA on the data. So, my data is in MySQL. So, I have to load the data from MySQL onto the Python. So before loading the data, we have to import the necessary libraries. Here, I have written a code to import the necessary libraries. Like here, I have imported pandas, matplotlib, cbon, and etc. And later on, I have used create engine function. This function is used to establish a connection between MySQL and Python. So here, I have used some connection parameters like user, PW stands for password, and DB is nothing but database. So after making connection, I have to get the data from database. So here are the two lines of code to get the data from database. So data description. Coming to the data description, basically I have a sample data set I have told before, like it is in MySQL. So the data set basically is about sales transaction information. So it contains 169 rows and 7 columns. And the 7 columns are, first one is the transaction ID, which is a unique identifier for each sales transaction, and customer ID, which is a unique identifier for each customer, and product ID, which is a unique identifier for each product sold, and the product category is the category to which the product belongs. The quantity is the number of products purchased in the transaction, and price is the price of each product unit. So, and this is the data description about my data set. And later on, I have performed EDA, like I have written code for to find the number of rows in the data set, to find the number of columns, to find number of categorical columns, to find number of numerical columns, and all of those things. And the output is on the right side of the screen. So here comes the output. The total number of rows present in my dataset are 169, and the total number of columns are 7, and the number of categorical columns are 4, and the number of numerical columns are 3. And the later on is the code to display a few rows, and then the null values in the dataset, which are 0, and then the descriptive statistics, which is like count, mean, standard deviation, minimum, and maximum. And later on, coming to the visualization part, I have done here a bar plot, a scatter plot, a histogram, and a box plot also. So this is the ADA. So by seeing all these things, it takes almost 15 to 20 minutes to write this code and to execute them and to understand what the data contains and all those things. That is nothing but we are putting 60 to 80% of our efforts into EDA. So there is an option called Auto EDA where we can reduce all the time and effort. We can see how coming to the Sweetviz part, here comes the Sweetviz code. So as we told earlier, we will use just a few lines of code to perform EDA by using Sweetviz. Here comes the few lines of code. First of all, here I have imported the necessary libraries like pandas and Sweetviz, and later on I have loaded the dataset into pandas data frame. And here I am executing this part, and I will show you the result on the right side of my screen. Here comes my dimensions, like there are 169 rows and 7 columns existed in my dataset. And later on, after loading the data, I am generating a report using sv.nls function here. So after executing this, I'll get a Sweetviz report, which I will show you in just a minute. So here comes our Sweetviz report. This is the Sweetviz report. Here, this is the overview of the dataset, like what are the total number of rows and what are the total number of columns present, and also the description of each and every column of my dataset. Like I have told, there are 7 columns total: the transaction ID, customer ID, product ID, etc. And it says each and every description about each and every column. So here also comes the descriptive statistics like maximum, median, minimum, standard deviation, range, etc. All of those things. And also it shows the most frequent values, smallest values, largest values, and all those. So we are getting this report in just a few lines of code. So what is the conclusion that we have learned? Like auto EDA reduces the time and effort which requires a lot in traditional EDA. So hope you understand. Thank you.